Imagine waking up in a tiny village perched on the edge of the Sahara Desert, or deep within the lush, tangled heart of the Amazon rainforest. Now imagine logging onto a video call with zero lag, downloading huge files in seconds, and streaming ultra-high-definition documentaries, all seamlessly, as if you were sitting in a downtown skyscraper in Tokyo or London. This is not a scene from a futuristic sci-fi movie. It is the unfolding reality of our planet, powered by a silent revolution high above our heads. The next chapter in global connectivity is being written not in the clouds, but far beyond, in the stars. The question is, who will shape this new era? Who will benefit? And who might be left behind in the shadow of this technological leap? Let's zoom out for a moment and look at how we got here. For many decades, global communications relied on undersea cables, telephone wires, and, later, geostationary satellites perched thousands of kilometers above Earth. These satellites, operating in lower frequency bands like C-band and Ku-band, served us well, enabling the first satellite TV, long-distance phone calls, and basic internet. But as the 21st century roared forward, the world's appetite for data exploded. Streaming services, cloud computing, telemedicine, smart cities, the Internet of Things. These innovations have driven demand for bandwidth into the stratosphere. In fact, over the past 10 years, global internet traffic has grown by more than a factor of 30, with billions of devices hungry for instant access. But the old systems could not keep up. Lower frequency bands have a limited capacity and relatively slow speeds. Traditional ground stations, those iconic fields of giant metal dishes, were expensive, cumbersome, and slow to adapt. Each dish could only communicate with one satellite at a time, making them ill-suited for the tsunami of satellites now circling the planet. Enter K-band technology, operating at much higher frequencies, between 27 and 40 gigahertz. K-band satellites can transmit data at blazing speeds, offering far broader bandwidths than ever before. What does this mean for the average person? Imagine downloading a feature-length high-definition movie in seconds instead of minutes. Picture a doctor in rural India conducting a real-time video consultation with a specialist in Paris. Envision disaster relief teams streaming live drone footage from hurricane-ravaged islands to command centers continents away. Ka-band is the invisible backbone enabling all of this and more. But speed and bandwidth are only half the story. The true revolution is unfolding on the ground, in the technology that connects us to the stars. Gone are the days of mechanical dishes lumbering across the sky. Today, a new breed of ground station is emerging, the phased array antenna. These are not your grandfather's antennas. Phased array systems are marvels of engineering, using hundreds or even thousands of tiny elements working together to electronically steer their beams. This allows a single gateway to connect to dozens of satellites at once, instantly switching connections as satellites move overhead. Celestia UK, a pioneering company based in Edinburgh and part of the pan-European Celestia Group, has just announced a major breakthrough. At the UK Space Conference in 2025, they revealed they have begun pre-production of the world's first commercially ready Ka-band multi-beam gateway. This is not just a technical milestone. It is a signal that the era of ultra-flexible, high-capacity, and scalable ground stations has arrived. According to Dr. Malachy Devlin, CEO of Celestia UK, with the green light to move ahead, our teams have already started work on the first pre-production units of the K-band gateway, showing that the era of electronically steered gateways has now arrived. This marks a key stage in the evolution of our work on the UK Space Agency-supported Sunrise project with the European Space Agency and Eutelsat OneWeb as phased array systems transition into commercially viable solutions. What makes this gateway so special? For starters, it can track and communicate with up to 28 satellites at the same time, far more than any traditional system. During tests with the JOESat satellite over a 9-month period, the gateway proved it could maintain reliable, high-speed connections even in challenging conditions. This means that high-throughput satellite constellations, like those being launched by Eutelsat OneWeb and other players, can deliver on their promise of seamless, global coverage. But why is this happening now? The answer lies in the explosive growth of low Earth orbit, or LEO, satellite constellations. Unlike traditional geostationary satellites, which hover over a fixed spot 36,000 kilometers above the equator. LEO satellites zip around the planet at altitudes of just a few hundred to 2,000 kilometers. This proximity dramatically reduces latency, the delay between sending and receiving data, which is critical for real-time applications like video calls, online gaming, remote surgery, and autonomous vehicles. In the last 5 years alone, the number of LEO satellites has soared, with companies like SpaceX, OneWeb, and Amazon's Project Kuiper planning to launch thousands more in the coming years. These vast constellations promise to blanket the planet in fast, reliable internet. But they also create an unprecedented demand for ground stations that can keep up. Each LEO satellite is only in view of a ground station for a few minutes at a time. To provide continuous coverage, gateways must be able to connect to multiple satellites simultaneously, hand off connections smoothly, and operate with near-perfect reliability. This is where the magic of phased array antennas and Ka-band technology comes in. The UK is positioning itself as a global leader in this new space race. Through strategic investments like the Sunrise project, backed by the UK Space Agency, the European Space Agency, and industry giants like Eutelsat OneWeb, the country is funding groundbreaking projects such as Celestia's Ka-band gateway. In May 2025, the UK Space Agency announced a grant of £1.3 million to Orbit Fab, supporting innovation in space refueling as part of the Sunrise program's broader goals. Industry experts are bullish on the potential. Simon Watts, a senior analyst at Space Tech Partners, notes, Ka-band multi-beam gateways are critical for unlocking the full potential of LEO constellations, enabling high-bandwidth applications and driving down costs. Dr. Pacome Revillon, CEO of Euroconsult, adds, the demand for flexible and scalable ground station solutions is growing rapidly, creating significant opportunities for companies like Celestia UK. The numbers are staggering. The global Ka-band satellite market is projected to reach over $43 billion by 2027, fueled by surging demand for high-throughput connectivity. Satix CFI, a leading technology provider for JoeySat, secured a $29 million contract in the first quarter of 2025 to supply advanced communication components, underscoring the intense competition and investment pouring into this sector. But as with any revolution, challenges loom on the horizon. The boom in satellite launches is stretching infrastructure to its limits. The Svalbard Satellite Station, one of the world's most important gateways for polar orbiting satellites, is expanding its Ka-band capabilities by 20% in 2025 just to keep pace. Meanwhile, the average latency for Ka-band satellite internet has dropped by 15% in the past year, making real-time applications more practical than ever. Yet every improvement brings new hurdles. Let's talk about the risks. As more satellites crowd orbital highways, the chances of collisions and the creation of dangerous debris increase. Space is no longer the empty, boundless void we once imagined. In fact, experts warn that we are approaching a tipping point, a scenario known as the Kessler syndrome, where one collision could trigger a cascade of debris, threatening the safety of space operations for everyone. Melanie Strickland, CEO of Slingshot Aerospace, puts it bluntly. Real-time space traffic management is becoming just as critical as air traffic control in aviation, and advanced ground stations like Celestia UK's are essential for ensuring the safety and sustainability of space operations. There's also the issue of signal interference. With more satellites transmitting in the same frequency bands, the risk of overlapping signals and outages grows. This is especially problematic as bandwidth-hungry applications like 4K video streaming, telemedicine, and self-driving vehicles become ubiquitous. But innovation is rising to the challenge. Researchers at the University of Surrey, a key Sunrise project partner, have demonstrated new AI-powered interference mitigation techniques for Ka-band systems. These smart tools can detect and resolve interference in real time, keeping connections clear and reliable even in crowded environments. On the regulatory front, the landscape is changing rapidly. In June 2025, the United States Federal Communications Commission approved new regulations to streamline licensing for Ka-band ground stations, slashing deployment timelines and reducing bureaucratic hurdles. Across the Atlantic, the European Space Agency has pledged to increase investments in space-based 5th and 6th generation wireless technologies by 30% by 2026. These moves are designed to accelerate the rollout of next-generation satellite services and ensure that Europe remains at the forefront of global innovation. Eutelsat OneWeb, one of the sector's leading players, plans to launch its next batch of LEO satellites with enhanced Ka-band payloads in the third quarter of 2025. These satellites will further improve global coverage, especially in underserved regions like the Arctic, Sub-Saharan Africa, and remote island nations. Let's pause and ask, what does all this mean for you, for your community, for the world? First, this new wave of Ka-band multi-beam gateways could finally close the digital divide that has persisted for decades. Today, nearly half of humanity, over 3 billion people, still lack reliable internet access. This is not just a technological issue, it is an economic and social barrier that locks people out of education, healthcare, and opportunity. Imagine a child in rural Peru logging onto a virtual classroom, or a farmer in the Australian outback using smart sensors to optimize crop yields. With Celestia UK's new gateways able to track and communicate with up to 28 satellites at once, coverage black spots could soon be a thing of the past. Consider the impact on disaster relief. When hurricanes or earthquakes strike, terrestrial networks often collapse. In such moments, satellite connectivity becomes a lifeline. With high-speed, low-latency Ka-band connections, emergency teams can coordinate responses, transmit maps and images, and reach survivors faster than ever before. In 2022, during severe floods in Southeast Asia, satellite internet played a pivotal role in maintaining communications when ground infrastructure was washed away. With next-generation gateways, these life-saving capabilities will become even more robust. The promise extends to business and economic development. Small businesses in remote areas will be able to participate in the global digital economy, selling products online, accessing cloud-based tools, and reaching new customers. Schools and clinics in the world's hardest-to-reach places will gain access to the same resources as their counterparts in major cities. This democratization of technology could ignite a wave of innovation and entrepreneurship, fueling growth where it is needed most. But as with every technological leap, new questions and risks emerge. The rush to launch thousands more satellites is crowding orbital highways, raising fears of collisions and dangerous debris. Space is becoming busy, and the consequences of mismanagement are global. There is real concern that without effective space traffic management, a single incident could jeopardize entire constellations. Signal interference is another looming challenge. More satellites mean more signals, and more chances for overlap and outages. This is especially critical as applications like telemedicine, financial transactions, and emergency communications become satellite-dependent. AI-driven solutions, like those pioneered at the University of Surrey, offer hope. But the race is on to keep pace with the scale and complexity of the problem. Regulatory frameworks must also evolve. Governments and industry must collaborate to set standards, manage spectrum allocation, and enforce safety protocols. The streamlined licensing processes announced in the United States and the ambitious investment plans in Europe are promising signs, but the pace of innovation is relentless. Only constant dialogue and global cooperation will ensure that new technologies serve the many, not just the few. So what can you, watching this now, take away from this revolution? First, recognize that the digital divide is no longer fixed. If you live in a rural area or work in an industry where connectivity once seemed impossible, the coming years could bring opportunities never seen before. Businesses, schools, and clinics in hard-to-reach corners may soon log on at lightning speed, opening doors to education, telehealth, and economic growth. Second, keep an eye on partnerships and local projects. Collaborations like the UK's Sunrise project, supported by the European Space Agency and private innovators, are paving the way for real, on-the-ground change. If you're an entrepreneur, a student, or a tech enthusiast, these are the programs to watch, and maybe even get involved in. The space sector is hungry for talent, and the ripple effects of innovation will touch every industry, from agriculture and healthcare to finance and logistics. Third, understand that this technology is not just about faster Netflix streams or smoother video calls. It is about building a resilient, global infrastructure for the next generation of digital services. Everything from smart agriculture and precision forestry to real-time disaster relief and climate monitoring. The integration of satellite and terrestrial networks will power the rise of global 5th and 6th generation wireless infrastructure, supporting applications like autonomous vehicles, augmented reality, and the Internet of Things on an unprecedented scale. Let's not forget the human stories behind these breakthroughs. The very first prototype of Celestia UK's phased array gateway was not built in a gleaming megalab, but in a modest Edinburgh workshop, by a dedicated team of fewer than a dozen engineers. Their innovation is now poised to reshape the world. It is a powerful reminder that revolutions often begin in unexpected places, and that the next leap forward might be happening in your own neighborhood. The economic implications are equally profound. The expansion of satellite internet could disrupt existing telecom markets, forcing traditional providers to innovate or risk obsolescence. New business models will emerge, from pay-as-you-go connectivity in developing regions to ultra-low latency services for financial trading and remote surgery. The infrastructure built today will underpin the digital economies of tomorrow, shaping the fate of nations and industries alike. There are lessons here from history. Just as the railways of the 19th century connected distant cities and fueled the Industrial Revolution, or as the deployment of undersea cables linked continents in the 20th, the rollout of Ka-band multi-beam gateways may be remembered as the network that truly united the globe. But, as with those earlier revolutions, the benefits will not be evenly distributed unless we make deliberate choices to include everyone. So here's your call to action. If you want to stay ahead in global tech and economics, hit subscribe and join the conversation in the comments. How would universal connectivity change your life, your business, or your community? What opportunities and challenges do you see on the horizon? The future is being built right now, high above us, by innovators, engineers, policymakers, and dreamers. The story of universal connectivity is still being written, and you could be a part of it.